Okay, so today we are going to be focusing on autoimmune diseases, immunodeficiency diseases, and allergies. Basically, these are three examples of the immune system either not working properly or being attacked. So we're going to start off by looking at autoimmune diseases. And an autoimmune disease is essentially when the body's immune system attacks its own cells. So it's the immune cells attacking regular body cells, okay? So usually that happens due to the immune system cells not picking up on self-antigens that they should. So hopefully you remember that all cells in the body have self-antigens that identify them as part of the body. But in these autoimmune diseases, the immune cells fail to recognize them. They believe that they are foreign material, so they attack them. So I've got the disease multiple sclerosis as an example. And in multiple sclerosis, the T cells fail to recognize the cells that make the myelin sheath around neurons, which are your nerve cells. So you'll see down at the bottom, here, I've got a healthy nerve cell. So we've got the nerve there, and it's normally covered with a myelin sheath made of something that we call Schwann cells. And this insulates the nerve, okay? That's how a healthy person would be. But for somebody suffering from multiple sclerosis, their T lymphocytes have attacked the myelin sheath. And as a result, it's either much thinner or in some cases it is fully absent over nerves, okay? So as a result of that, the symptoms of multiple sclerosis will be tiredness because the nerve impulses have to work harder. They'll have tremors, so shaking because the nerve impulse won't be as strong. They may have a loss of feeling, they may have a loss of coordination, and just general weakness, okay? So that's multiple sclerosis, and it's an example of an autoimmune disease because immune cells from the body, which in this case are the T cells, are attacking regular body cells, which in this case is the Schwann cells that make up the myelin sheath. So that's how our neurons should be, insulated. Somebody with multiple sclerosis will not have insulated neurons. Next, we're looking at immunodeficiency diseases. And immunodeficiency diseases are when a pathogen is targeting immune system cells. So the most famous immune system disease is HIV, which stands for human immunodeficiency virus. What HIV does is it attacks what we call CD4 cells, which are a type of T helper cell. It replicates inside of them and then it ultimately destroys them and then moves on to other CD4 cells, so other T helper cells. And obviously, the T helper cells have got a really important role in the immune system. They're involved in the cell-mediated response. They're involved in the humoral response. So if they're getting destroyed, the immune system is getting severely weakened, and it gets weaker and weaker and weaker over time. Eventually, HIV leads to AIDS, which is acquired immunodeficiency syndrome. And at that point, that's when the HIV infection is so severe that the body cannot fight basic infections. And even a really basic common cold that would make a healthy person ill for a couple of days can end up being fatal. So AIDS is a disease when the immune system has essentially failed and it leaves the body vulnerable to even very minor infections. Just a word on terminology. Being HIV positive is not the same as having AIDS. HIV positive means they have the virus, it is infecting their cells, but it only becomes AIDS when it reaches a certain point when the immune system is very severely compromised. Fortunately, while HIV isn't curable, we're getting better and better drugs all the time, and nowadays people who are diagnosed with HIV don't have that different a life expectancy to people who don't. But unfortunately, in the developing world, AIDS is still very common as people can't get the same access to those drugs. And also, while in developing countries they may have access to those drugs, they still have to take a lot of drugs, for the rest of their lives. So even though it's maybe not the quick death sentence it once was, it's still a serious illness, a serious virus to have. So that's an immunodeficiency disease. So the body's immune cells are being attacked. That's different to the autoimmune disease like multiple sclerosis, when the body is attacking its own cells. So the third thing I wanted to talk about is allergic responses, which we did talk about briefly in the earlier parts of the immune system. So before we talked about mast cells, which are the cells that contain histamine in the which is involved in the inflammatory response. And these mast cells are also covered in antibodies that we call IgEs. So we've got a few there. So what essentially happens in an allergic response is an allergen binds with the antibodies, the IgEs, that are bound to the mast cell. Remember, an allergen is essentially something that makes the body believe it has got an infection, even though it doesn't. And as a result, the mast cells do what they would do when there is an infection, and they'll release histamine, but they're releasing it unnecessarily. So all the regular effects will happen that lead to inflammation. And then also it can result in severe cases in tubules in the lungs actually constricting and making breathing difficult. And in that case, anaphylactic shock can occur. So an allergic response is basically caused by an allergen binding with these antibodies that are bound to the mast cells. It's interpreting that incorrectly as there being an infection, and it releasing its histamine in huge amounts that can cause minor symptoms, or in some cases really severe symptoms of an allergic response. So those are just 3 examples of the immune system not working to different effects. So yeah, there'll be some work on Google Classroom in relation to that.